Hello friends, welcome to Learner's Planet. Friends, this is our third session for Trigonometry Advanced level problems. In the previous two sessions, we have already discussed so many questions, so many problems. I'm sure you are gaining the confidence in this topic now. And in this session particularly, I'll just suggest you as the question appears on the screen, just pause the session and try to do the question on your own. Okay, so let's move. Now, sine 10 degree plus sine 20 degree plus sine 30 degree till sine 360 degree is equal to. Now, definitely looks like a tedious problem, but if you know the basic properties of trigonometric functions, you can do this problem very easily. See, sine 360 will be 0, right? That is 360 is nothing but 2 pi. So sine 2 pi is 0. Then see, there is a gap of 10 and sine 350 will be sine 360 minus 10. So that is a sine 2 pi minus theta. Now sine 2 pi minus theta is nothing but minus sine theta, right? So here we are having sine 10 and sine 350 can be written as minus sine 10. That is 360 minus 10. Sine 360 minus 10 is sine 350. So sine 350 can be written as minus sine 10 degree. So sine 10 minus sine 10, they will be cancelled. Similarly, sine 20 and sine 340, that is minus sine 20, they will be cancelled. Similarly, all the terms will be cancelled. So you will be getting 0 finally. Okay. Okay, minimum value of this expression. Now this is going to be an interesting question. Let's try this. Sine a plus cosec a whole square cos a plus sec a whole square. So just remove the square and just do the expansion. Sine square a plus cosec square a plus 2 sine a cosec a, that will be nothing but 2, right? Similarly, we have cos square a plus sec square a plus 2 cos a sec a, that will also be 2. Now this is 1. So 1 plus 4, 5 we have already got. That is the constant value. Now minimum or maximum depends upon this. That is sec square a plus cosec square a, right? So whatever the minimum value we get for sec square a plus cosec square a, we add 5 to that. That will be the minimum value of this expression. Okay. So cosec square a plus sec square a, I can write 1 upon sine square a plus 1 upon cos square a, right? So if I take LCM, I'll be getting cos square a plus sine square a upon sine square a cos square a. So that is nothing but 1 upon sine square a cos square a. In the numerator we have sine square a plus cos square a, that is nothing but 1, right? Now in the previous session we have discussed the expansion of sine 2a, that is 2 sine a cos a, right? So here I am having sine square a cos square a. So what I do is I multiply and divide by 4. So that is 4 upon sine 2a whole square. Now 5 already I have. Now the minimum value of this expression, if I have to get the minimum value of this expression, then sine 2a should be maximum. So the maximum value of sine 2a will be 1, right? So sine 2a is 1, then the square of sine 2a, that will also be 1. So minimum value of this expression will be 4. Okay, 5 we already have plus 4, that means the minimum value of this expression will be 9. And since this is a square, whether you take minus 1 or 1, that really doesn't matter, because if you put minus 1, still the square will be 1. So do not get confused with maximum and minimum over here. The minimum value of this expression will be nothing but 4. So 5 plus 4, 9, right? Or I mean to say the minimum value of sine 2a is minus 1 and maximum value of sine 2a is 1. So square will be 1 in both the cases. So do not get confused. I'm sure you are clear. If 3 sin theta plus 4 cos theta is equal to this, then 3 cos theta minus 4 sin theta is equal to what? So there are two ways of solving this problem. I explain both the ways. First of all, I just divide this entire expression by 5. So I just get it 1 over here. I take this triangle, assume this angle to be x, right? Because theta is already used. So now this is 3, this is 4, and this is 5, right? So 3 by 5 is cos x. So cos x sin theta plus sin x cos theta, right? cos x sin theta plus sin x cos theta. That means sin theta plus x is equal to 1. That means theta plus x is equal to, I can say, 90. And similarly over here I have to find out the value of this expression. I divide it by 5. So 3 by 5 is cos x and 4 by 5 is sin x. So this is cos x cos theta minus sin x sin theta, that is nothing but cos theta plus x, right? Theta plus x is 90, so cos theta plus x is cos 90, and that is 0. So very simply you can solve it, right? And the other way, that also I explain. Now here you can see that the coefficients are changed. Here sin theta 3 and here cos theta into 3. 4 cos theta and 4 sin theta. So the coefficients of sin theta and cos theta are interchanged. So what you can do, just square this, right, both the side. So it is 9 sin square theta plus 16 cos square theta plus 3 into 4 into 2, that is 24 sin theta cos theta is equal to 25. Now we want the coefficient to be interchanged. So instead of sin square theta, I write down 1 minus cos square theta. So it will be 9 minus 9 cos square theta. Similarly, this is 16 minus 16 sin square theta plus the same story is equal to 25. Now I take this and this in a single bracket. Now this will be what? 9 plus 16, 25 minus 3 cos theta minus 4 sin theta whole square, right? Because 3 into 4, 12 into 2, once again you'll be getting the same thing since I have taken minus outside the bracket. So it will be minus 9 cos square theta minus 16 sin square theta plus this. Right? So minus I have taken common. So this is positive, then this will be negative, right? So it is the 3 cos theta minus 4 sin theta whole square is equal to 25. So this is cancelled. That means this expression is nothing but equal to 0. So this is also one approach, and the previous approach was really simple. If you just see this sort of expression, try to apply this approach. Okay, the problem will be very easy for you. If you do so many questions on this approach, then definitely it will come to your mind very quickly when you see this sort of problems in your exam. Okay, let's move further. Now this expression, problem, sin theta 1 plus sin theta 2 plus sin theta 3 is equal to 3, then cos theta 1 plus cos theta 2 plus cos theta 3, no need to go for any sort of paperwork. The maximum value of sin theta 1 is, sin theta is 1. So, and that you get when theta is equal to 90 degree or other values also. But in the first 0 to 360 degree, 90 degree is the option where you get the value of sin theta as 1, right? So this theta 1, theta 2, theta 3, all of them, theta 1, theta 2, theta 3, all of them are 90 degree, right? Then only you will be able to get 3. So because you are getting the maximum value. So if theta 1, theta 2, theta 3, all of them are 90 degree, then cos 90, cos 90, cos 90, that will be 0. So no need to go for any sort of paperwork, right? Maximum and minimum values of sin 4 theta plus cos 4 theta are. Once again, a simple problem. See, I suppose this to be P. Sin square theta whole square plus cos square theta whole square. What I do is I add and subtract 2 sin square theta cos square theta, right? Minus 2 sin square theta cos square theta. So this is what sin square, I'm sorry, 2, correct. Sin square theta plus cos square theta whole square, this expression. And minus 2 sin square theta cos square theta, right? Now this is what? 1. And this, once again, I'll be using the formula for sin 2 theta, that is 2 sin theta cos theta. Okay, so it is, I want 2 sin theta cos theta, but we are having 2 sin square theta cos square theta. So I'll make it 4 by 2, that is 4 sin square theta cos square theta, that will be sin 2 theta whole square by 2. Now since this expression is being deducted, right? So if I have to get the maximum value, I need to see when this expression is minimum, right? Since it is a square, sine 2 theta, the minimum value is definitely -1, but when if it is squared, it will be 1 only, right? So if I have to find out the maximum value of this expression, this entire expression, I should get the minimum value of this expression. So minimum value will be nothing but 0, right? So P will be 1 minus 0, that is 1. So maximum value of P is 1. Just listen to me carefully. We have already done this sort of problem, sine 2 theta whole square. Earlier we discussed the same case. Sine 2 theta, the minimum value is -1, but since there is a square over here, the minimum value of sine 2 theta square will not be 1, right? So you have to be careful. The minimum value of sine 2 theta is -1, right? But square will not be -1. So to get the minimum value of this expression, sine 2 theta, since it is a whole square, it's a square term, so sine 2 theta we have to assume to be 0. So the maximum value of P will be 1, right? And minimum value, for that we have to see this expression to be maximum. That is this expression to be maximum. So maximum value of sine 2 theta will be 1, right? And 1 and square, so that's 1 by 2. So 1 minus 1 by 2, that's 1 by 2. So this is maximum value, this is minimum value. Have to be careful about it. We have already done this sort of problem when we discussed the case of this, right? Here we were getting in the denominator, we were getting sine 2 theta whole square. So at that time also I discussed the same thing, -1 and 1, because if it is a square term, even -1 will produce the maximum value, and 1 will also produce the maximum value. We cannot have 0 since it is in the denominator. Okay, so be very clear with all these concepts. I hope you are getting my point. So the answer to this problem is 1.5. And apart from that, I would like to share a trick over here. See, maximum value you will be able to get when one of them is 0, right? Maximum value you will get when one of them is 0. So you can take either sine theta as 0 or cos theta as 0. So if you take sine theta as 0, that means theta is equal to 0. So cos 0 will be 1. So maximum value will be 1, right? And minimum value you will get when both these expressions are equal, that is sine 4 theta is equal to cos 4 theta. So there is a possibility, a single possibility for that, that is theta is equal to pi by 4, right? Pi by 4, that means 45 degree. So sine 45 degree, that is 1 upon root 2. So 1 upon root 2 4 times, that is 1 upon 4, and cos 4 theta, that's same 1 upon 4, so that's 1 by 2, right? So maximum value is 1 and minimum value is half. So that's a shortcut you can say, or a trick you can say, if you don't want to go for lengthy method, that is the previously discussed method. That was actually conceptual method, and this is like a trick. And once again, the reason behind this is AM is greater than GM, that I discussed. Sine 4 theta plus cos 4 theta divided by 2. See, this is just for your knowledge. Otherwise, you just have to work up till here only, right? That is arithmetic mean, that should be greater than their geometric mean. Geometric mean will be product of sine 4 theta into cos 4 theta in square root. So if it comes out of the square root, it will be sine square theta cos square theta. So that's greater than equal to, so this 2 I remove. So sine 4 theta plus cos 4 theta, it should be greater than equal to 2 sine square theta cos square theta. Once again, sine 2 theta is 2 sine theta cos theta, so I make this as 4 and divided by 2. So that is nothing but sine 2 theta whole square by 2. Okay, so sine 4 theta plus cos 4 theta is greater than equal to sine 2 theta whole square by 2. So maximum value of sine 2 theta will be 1. So 1 square by 2, that is 1 by 2. That means sine 4 theta plus cos 4 theta definitely will be greater than 1 by 2. That means minimum value of this expression will be 1 by 2, because they are always greater than equal to 1 by 2. Okay, so this is also this is like the explanation of this trick. And why I'm using this trick? Because sine 4 theta and cos 4 theta, both of them are positive quantities. That is necessary to apply this concept of AM is greater than GM. In the similar lines, we can say the minimum value of sine 6 theta plus cos 6 theta is. So once again, arithmetic mean sine 6 theta plus cos 6 theta by 2 is greater than equal to their geometric mean. That is, if it comes out of the square root, it will be sine cube theta cos cube theta. So I just write 8 by 8. So this is 2 sine theta cos theta whole cube, that is sine 2 theta whole cube by 8 into 2, right? This 2 I'm taking it over here. So sine 6 theta plus cos 6 theta is greater than equal to sine 2 theta whole cube by 4. So maximum value of sine 2 theta is 1, 1 cube is 1. So it's always greater than 1 by 4. So minimum value of sine 6 theta plus cos 6 theta will be 1 by 4, right? Maximum value of this expression will be 1 by 4 this side, and this expression is greater than equal to this. That's why the minimum value of this expression will be 1 by 4. So if you have to choose the maximum value, then put one of them as 0, and if you have to choose minimum value, then both should be equal. That is sine 6 theta is equal to cos 6 theta. That means theta is equal to pi by 4, 45 degree, right? So this is one explanation, and this is like a short trick by which you can do the problem in seconds. So sine 6 theta, that is sine pi by 4, that is sine 45, that is 1 upon root 2. So 1 upon root 2 whole cube will be 1 upon 2 root 2. So 1 upon 2 root 2 plus 1 upon 2 root 2, that is, I'm sorry, we have to take it as 6 power. So 1 upon root 2 raised to 6 is equal to 1 upon 2 cube, that is 1 upon 8. So 1 upon 8 plus 1 upon 8 is 2 by 8, that is 1 by 4. Okay, so for minimum value, take theta as 45 degree, because in that case both of them are equal, and for maximum value take one of them as 0. As I've already explained you, a plus b by 2 is greater than equal to root ab. So arithmetic mean is always greater than equal to geometric mean. They will be equal if a is equal to b. So maximum, that means the minimum value of arithmetic mean is equal to geometric mean when both the data are equal, right? So if a is equal to b, then this side also you will get a, this side also you will get a, right? So if you have to find out the minimum value of this expression, then both the values should be equal. Okay, I hope you are getting the method as well as the trick. Now we have this interesting question, the minimum value of this expression. See, we have already discussed the minimum and maximum value of a sin x plus b cos x, that lies between minus root of a square plus b square and a square plus b square, right? So that lies between these two. Here the explanation, or the I can say derivation, I have already explained in, I guess, 1 or 2 session before. So I hope you are clear with the explanation. So a sin x plus b cos x, that lies between minus of root of a square plus b square and root of a square plus b square, right? Now I assume this expression to be p. Just listen to me carefully. We have to find out the minimum value of p, right? This entire expression is p, that means we have to find out the minimum value of p. If we have to find out the minimum value of p, that means the denominator should be maximum, right? So maximum the denominator, minimum the value of entire expression, right? The more the denominator, the less the entire value. Okay, so we have to find out the maximum value of, I just write 6 minus 2 sin x minus, in fact I can take 2 as common, plus root 3 cos x. So I have to find out the maximum value of this, right? So maximum value of this, see, I have a as 1 over here and b as root 3 over here. So this expression will be will take value as minus of 2 also and 2 also, right? But since we have minus sign over here, so to make this entire quantity maximum, if I take sin x plus root 3 cos x, the maximum, the minimum value, that is minus 2, right? So that minus 2 into this minus 2 will produce plus 4. So maximum value will be obtained as 10. Okay, getting my point? The maximum value of this expression will be 10. And definitely minimum value will be 6 minus 2 into sin x plus root 3 cos x. If I take this expression as 1 plus root 3 positive 2, then I'll be getting the minimum value, that is 4, right? So see, I have to find out the minimum value of this expression. For that, the denominator should be maximum. So maximum denominator is 10. So maximum denominator is 10. That means minimum value of P is 1 by 10, right? And if minimum denominator is 4, then maximum value of P is 1 by 4. Okay, so this expression will lie between 4 and 10, 1 by 4 and 1 by, 1 by 10 and 1 by 4. Maximum value of this minimum value of this expression will be 1 by 10, because maximum value of the denominator is 10. Okay, or in other words, I can say the denominator cannot take more value than 10. So this entire expression cannot have the lesser value than 1 by 10. Okay, so the lesser value than 1 by 10 cannot be achieved. That means 1 by 10 is the minimum value that can be achieved in this expression, from this expression. Okay, so in case of maxima minima problems, you have to be very careful, because sometimes the students get confused how you will get how they get the maximum values and minimum values. So conceptually you should be clear, right? Now maximum value of this expression, once again an interesting problem. I assume it to be P. So P is equal to, I take minus 6 as common, sine square theta minus 2 sine theta. So a square minus 2ab, so I add 1 and deduct 1. So if I deduct 1, it will be minus 1, that minus 1 into minus 6 plus 6. So precisely out of the bracket it will be plus 6. So this is minus 6 sine theta minus 1 whole square plus 6. Now I have to find out the maximum value of P, right? So to be able to find out the maximum value of P, we have to find out the maximum value of this expression. So the maximum value of this expression, see, sine theta minus 1 whole square, that's either a 0 or a positive quantity, right? So if we get a positive quantity, suppose sine theta I take as minus 1. So minus 1 into plus minus 1, that will be 2. Minus 2 whole square will be 4. So minus 6 into 4, you will be getting minus 24. So in that case, P will be minus 24 plus 6, that is minus 18. Now the other extreme is when sine theta is equal to 1. So if sine theta is equal to 1, 1 minus 1 whole square, that is 0. This entire quantity will be 0, will be getting the value as 6. So this is the maximum value that can be achieved from this expression, right? So this is the minimum value and that is the maximum value. Because in this entire expression only sine theta is variable, all other quantities are constant. So the maximum and minimum value of the expression will be dependent on sine theta only. Okay, so I hope you are clear. And we are asked about the maximum value of this expression, that is 6. So that is none of these, right? That maximum value of this expression, that means this expression cannot take a value that is more than 6, right? You can put up any values over here to verify, to get a confidence if you wish. Otherwise the maximum value will be 6 that I have proved over here. Now tan A plus cot A is equal to 4, then tan 4A plus cot 4A is equal to. These sort of problems we have discussed in our algebra sessions. See, tan A is suppose x, and this will be 1 upon x. So x plus 1 upon x is equal to 4, then we have to find out the value of x4 plus 1 upon x4. So that's pretty simple. X square plus 1 upon x square plus 2 is equal to 16, right? So that is 14. Then x4 plus 1 upon x4 plus 2 is equal to 196. So that is 194, right? Matter of seconds. So here x is 10a and 1 upon x is 10a precisely. Now this problem, sine x plus sine square x is equal to 1, then we have to find out the value of this expression. So what I do is I take cos 6x as common, then I have or I can say okay, cos 6x plus 3 cos 4x plus 3 cos square x plus 1. Now you should be able to identify the coefficients. That is, just a moment, I just changed the color of the pen. That's 1 3 3 1. That means it is a cubic equation. That means it is cos cube x plus 1 whole cube. Cos square x, I'm sorry, cos square x plus 1 whole cube. This is actually cos square x whole cube and this is 1 cube. So this entire expression is cos square x plus 1 whole cube, and outside the bracket we have cos 6x. Now if I have to take this inside the bracket, this 6 divided by 3 inside the bracket, cos square x will go. So it will be cos 4x plus cos square x whole cube. Right? Cos 4x plus cos square x whole cube. This expression can be converted to this. Now 1 minus sine square x is equal to cos square x. So cos square x is equal to sine x. So cos square x is sine x and cos 4x will be sine square x. So this is sine square x plus sine x whole cube. So that is 1. Okay, because sine x plus sine square x is 1, that's already given. So very simply you can solve this problem. You should be able to observe this 1 3 3 1, that's it. Okay, and that I have already shown you that Pascal's triangles, 1 2 1 1 3 3 1 1 4 4, I'm sorry, 1 4 6 4 1, that is x plus 1 whole square, that is x plus 1 whole cube, that is x plus 1 raised to 4, right? So if you can observe the coefficients, immediately you can convert this to this, right? So friends, that's it for this session. We'll take more problems in next session. Do revise this session and the previous ones. Bye bye.